Here's a reaction. Calcium phosphate reacts with silicon oxide and 10 moles of carbon to produce phosphorus, calcium silicon oxide, silicate probably, and carbon monoxide. What mass of P4 is produced when we start with 41.5 grams of calcium phosphate, 26.5 grams silicon oxide, 7.8 grams of carbon are reacted? All right, first thing, you got to figure out the moles of each of those because we don't want the grams. So, moles of reactants. Okay. 41.5 grams of Ca3PO4. I have no idea what the molar mass of calcium phosphate is. Does anybody know? 310? 310.3 grams per mole. So if you divide 41.5 by 310.3, you get 0.134. Okay, now I got different answers.
I said 1.3. She said 1.3.
Oh, I thought you said 1.5. It'd be 3 sig figs. That's calcium phosphate. We have 26.5 grams of silicon oxide. What's the molar mass of silicon oxide? What is it? 60.1? So that should give us 26.5. 0.441. And then carbon, 7.80 grams of carbon. Carbon's 12. 7.8 divided by 12. 0.650. Does everybody agree with those numbers? We're doing this in real time here. I do not have a key. I do not have a key. What did I say? All right. Does everybody agree with those numbers? Okay. So now we have moles of all our reactants. What's the next step? Divide by the coefficient from the reaction. So for calcium phosphate, we divide by 2. For silicon oxide, we're dividing by 6. And for carbon, we're dividing by 10. That should be 0.67. Are those the numbers? 0.067, 0.0735, 0.0650. Yep. Okay, so which one's limiting? Carbon is limiting, right? The lower number is the limiting. Okay. I don't know. It's like a video or something.
We should play.
It's like a socials class or something just over there, I think.
I think our chemistry minds would benefit if we played it out.
Use earbuds. All right, smallest number is limiting. So now, what are we even calculating here? What are they asking? What mass of P4 is produced? Okay, so We use our limiting reagent. You want the moles of the limiting reagent. This is the number, that's moles of carbon. So to find P4, we have 0.0650 moles of carbon. And then it's a stoichiometry problem. We know the moles, so now we're going across the mole bridge. The mole bridge is 10 to 1. Sorry? No, because this is the ratio, right? When you divide by 10. I mean, I guess you could just use that number and then multiply by the moles. But you want the mole. This is how many moles we have. This is the simplified ratio. You're going to get the same answer, though, because when you go across the mole bridge, it's 10 moles of carbon to 1 mole of P4. Yeah. So it does work out in the same. But we want the mass, right? So what's the mass of phosphorus?
31.
Sorry?
31.
So phosphorus is 31. It's 31.0. But we're not finding just phosphorus. We're finding P4, right? That's what phosphorus is in its elemental form. So it's 1 mole of P4 is 4 times 31. What's 4 times 31? 120, 124? Is 124.0 grams of P4. Your units all cancel, and you're left with grams of P4. So we're going to get points. 8.06 grams. Does everybody agree with that? Okay. So we have 8.06 grams of P4. That's part A. Check. How many grams of excess reactant will be left over? So how much of the calcium phosphate and the silicon oxide is left over? That's what they want to know now. Yep. You good? All right. All right. So to find leftovers, I guess this is B. Find leftover. It's a stoich question. So 0.650 moles of carbon. And then you use the mole relationship in the question. 10 moles of carbon react with 2 moles of calcium phosphate. So it's 10 moles of carbon. And they want to know the mass. And I know the molar mass of calcium phosphate is 41.5 grams. That's going to spit out
Wait, why is it 41.5 grams?
Isn't that the mass of it?
That's the massive one.
Oh, it's 310. That's the mass that we used. Sorry, it's 310 point whatever. That
10.2.
seemed very small. 310.3?
Yeah.
Sorry, peoples. $40.34. 40.34 grams of calcium phosphate what? That's what was used. Okay. Hmm? Yeah, it should be 3 sig figs. We'll round at the end. But you're right, it should be 3. 40.3. So the amount left over, you just subtract that from the starting amount, which was 41.5. Which is 1.2. 1.2 grams left over. All right, then we got to do the other one. Do you want to try carbon or silicon oxide on your own? We got to do silicon oxide. So same process. You try silicon oxide, I'll do it, and we'll see if we meet at the same spot. Oh my. I did it again. What'd you get? Are we ready? It's all right. Give me another minute. I put it up anyway. Should be 3.1. So same thing, 0.65 moles of carbon. The mole ratio is 6 to 10 times the molar mass of silicon oxide. Gives you the amount used. Subtract that from the amount you started with. You get the amount left over. All right? Do we feel comfortable with that? So the first step, these are long questions. First step is figure out the moles of the reactant. Divide by the coefficient. The lower of all those numbers is the limiting reagent. You then use that to find how much product, doing a stoic reaction. If they ask for the amount left over, use that moles, the mole bridge in the equation to get how much you used. Subtract that from how much you started with, and you're done. Okay? You just got to do a few practice questions because you are going to see a question like this on your test/quiz. Okay? So there's 1, 2, 3, 4 questions there with the answers, and I'll write out some work too. Please start those. And if we have